So here's what happens. So we obviously figured out that if we take 2 to the 31st, which is the maximum signed integer, which is 2,147,483,648, that offset we determined doesn't work. If we go past that, it still doesn't work. But here's what I found. Remember the 2 terabyte limit comes from the maximum unsigned integer multiplied by 512, since there's 512 bytes per sector. That gives you 2,199,000,000, 23,259,040. I don't know. 2,199,000,000, 23,259,000. I don't know. Somewhere around there. 2.2 terabytes or 2 terabytes, whatever. But I was thinking maybe the maximum or the offset can't be before the maximum assigned integer multiplied by that 512 bytes per sector, which is 2 to the 31st. Now the reason it's 2 to the 31st is because that's exactly half of 2 to the 32nd. The maximum assigned integer can deal with both positive and negative numbers. So since half of it is in the positive range and half of it is in the negative range, they're evenly distributed between each other. So in order to figure out how many positive numbers you can have, you just take 2 to the 31st. That's how many positive numbers there are. If there's one more negative, since 0 counts, I guess, towards positive. So there's one less there, it seems like. Anyways, it's not really. But if I go to here, this is like the megabyte where it still works. If I were to repartition it and offset it one more megabyte, which is 1,048,576 bytes over, then it stops working. Like, I can't read the entries or anything like that. And yeah, 2 to the 31st times 512 is just a little bit more than this, I believe. So here, let me show you some calculations. All right. Sorry, I can't talk. I'll do it on this monitor. The reason I'm using this program is because you could just about calculate unlimited amount of numbers, whereas calculators can only show like 15 numbers. But the high precision one can only do 50, but there seems to be no limit on this, at least until you make the computer like kind of crash trying to calculate stuff. But it's not going to crash on most systems because it only utilizes one core. So only one core will be hard, leaving the other 3 available to whatever, like, aborting the process. Anyways, like, double asterisk is the same as this. This doesn't work in Python, but the double asterisk does. Let's see, if I were to do a really big number, yeah, I could do that many digits. That's way more than 50, and it works just fine. But anyway, if I were to do 2 to the 31st times 512, there's that 1099511627776 versus 1099445567488 is described right here. This is slightly less than that. But if I were to take this, subtract 1099445567488, yes, that's in my memory, unfortunately, because I did a whole bunch of testing and now it's getting old at this point. Getting sick of this number. That's not important. Anyway, so that's how many there are left over. Let's assume that's how many bytes are left over. But if I were to take that number, 6060288, divided by 1,048,576, then you'll get the amount of megabytes there are. The reason we do megabytes is because that's the 1,048,576 is 1 megabyte. That's how many bytes are 1 megabyte. Now the reason we use that is because this is based off the base 2, just like literally everything else on here. And this is a number that's closest to 1,000,000, that's a power of 2. With the power of 10, 1,000,000 is obviously the closest, but this is the power of 2 that's closest to 1,000,000. So I guess that's really where that comes from. That's why we go based off of that. I'm going to be talking more about that in the video, so don't worry about that. Anyways, if I convert it, I get 63. So it's almost like there's 63% pre-allocated for something. I'm not entirely sure what. Don't quote me on any of this. Like, I understand that this definitely has to do with the maximum signed integer, but we don't have the full story, so I don't know what this comes from. But it's safe to say it has to do with the maximum signed integer. So, the 63 could either be, well, you see partition entry arrays on the master boot record use 64 bytes of data, 16 per entry, that's 4 entries total. But yeah, anyways, there's pre-allocated memory dedicated to the partition entries, which is 64 bytes. And perhaps it's on byte, well, this is not exact, but maybe if we count from 0 to 63 is 64, hence that part, but I doubt that's what it is. Another thing it could be is, if you notice on here, there's 63, hence that part, sectors per track. So it's almost like through the track that's pre-allocated, it has a little bit of tolerance with that. Actually, it doesn't quite, but yeah, there's that. But I don't think it's either of those, to be honest. You know, I'm just throwing ideas out in case any of you guys would happen to figure it out. I don't think it's any of those things, but those are possibilities, I guess. So yeah, this is just right before it starts working. So if I were to... Here, let's test it on that partition, which is J:, I believe. If I go to disk management... yeah, J:, is that one partition. I know it is because I did so much testing that I have gotten sick of. Anyways, that's the partition that it's on. It's based on the starting offset. I don't care how big it is as long as the starting offset is that specific number. So watch this. If I were to restart it and test it, I wish I would have put this on a RAM disk so it's faster, but we can deal with slower speeds for tonight. So if I go to here, as you can see, it says gparted live, which means it's able to read the menu entry file, which is great. However, if I were to go into gparted, where is it? Here, let's gparted 0.32. The AMD 64 one we determined works. So let's run that now. But then if I go in there and make the offset 1 megabyte over, like only one, it's going to quit working at that point. Let me just show you what goes on. So yeah, it's definitely the maximum signed integer. There's no argument against that, I would say. I mean, this is a little bit off, but you can't get any closer than that. It's within a couple million bytes. You can't get any closer than that, trust me. It could possibly be just a coincidence, because this is very close. Maybe the 63 does correspond with something. I have no idea what. I can't answer that question for you guys, but I think it's safe to say it has to do with the maximum signed integer or whatever. So, if I were to, let's pre-allocate 1 megabyte. Everything's still gonna fit. There's nothing booting off that partition, so I'm not worried about that. And then if I were to expand this by 1 megabyte, which basically shifts that partition over by just 1 megabyte, it shifts it over just by 1, then it'll shift it 1 over. Okay, this is, oh crap. Sorry, I didn't really think ahead. Oh, this is gonna go pretty quickly though. But if I shift it over just 1, then it should stop working. Okay, did it work? I hope this worked. What is up with that? I hate it when it does this. Oh, that should have shifted it 1 over. Okay, here we go. I don't know what happened before. I guess you needed to apply operations before you could do anything like that. But now, the reason I didn't want to delete the partition is because I have the stuff on there and I really don't want to go into Windows just to reconfigure it. Now if I were to run it 1 megabyte over, oh my gosh, gparted doesn't show up anymore because it doesn't read the file now. Let's take a look at the offset. Let's take a look at the offset though. I did like 6 hours worth of testing just to figure out the exact spot. This is it. Instead of it being 48,515, now it's 48,516. So it's 1 megabyte over, and that literally makes it stop working. So I really do think it's maximum assigned integer. That's what determines whether or not it can read the file or not. Some computer science stuff with the maximum 32-bit signed integer. So yeah, there you go. That's what I found. And then as for it running on GPT, what I found was that it doesn't work on GPT. Now, the Microsoft BCD can read the grldr at grldr.mbr. However, within that, when I use Grub DOS, it can read the menu entry. However, when I try to load gparted, that it has an error trying to mount the partition. So it can't fully boot gparted even though it can read it. So GPT will not work, but if you boot from GPT, the Microsoft BCD will not work according to what I've tested on both host and virtual. So that doesn't work. But then now I want to talk about when you want here, let me show you one more thing. So let's prove that I shifted it over exactly 1 megabyte. So this is the drive that I shifted. So let's get out our calculator, shall we? So before it used to say 1099445567488. Oh crap. Here, let's subtract. This is going to be a negative number, but if I did it the other way around, it would be positive. Ignore the negative. We're not going to pay attention to that part, alright? Then subtract 1099446616064. See? 1,048,576. Ignore the negative. Okay? It's like doing the swapping around the positive and negative charge when testing voltage. So yeah, 1,048,576, that's 1 megabyte. So there's proof that I shifted it just 1 megabyte over from the original. So yeah,